All right, now before we move on to the next DAX function, I want to take a moment here and pause and address a really important but nuanced point. And it has to do with some of the values that we've produced in our matrix visual so far. And you may or may not have noticed, but some of the measure totals may seem inaccurate or inconsistent depending on how they have been calculated, because they don't simply add up the visible values in the report. Let's take a look at this matrix here. I want you to take a minute, pause the video if you have to, and then when we come back, let me know if you notice anything strange or unexpected about these values. All right, did you find it? By now, you've probably realized that this total orders column is a little bit strange because the total of 25,164 doesn't equal the sum of the component rows above it. In fact, if we were to add up all of the accessory orders, bike orders, and clothing orders, we'd end up with something closer to 38,000, not the 25,000 that we're seeing. So what's going on here? Well, this is a perfect opportunity to talk about exactly how DAX is working and also how the data we're working with is really structured. So two important things I want to call out here. First, this value here in the total row, it's not calculated by the sum of the rows above it. Because these visuals don't use A1 style references, right? They're using filter context to determine these values. There's nothing that's saying like, hey, take this sum and I want it to equal cells C3, C2, and C1, right? It doesn't work that way. So this field here, it's calculated as an island. It has no awareness or visibility into the other values around it. In fact, it's calculated by evaluating this total orders measure without any filter context applied, meaning it's just removing the category name filter context. So it might not seem like a big difference, but it's critical and fundamental idea to help you understand how DAX really operates. So that's the first thing. The second thing that we need to call out here is how our total orders measure is actually working. And if you remember, we defined total orders using the distinct count. We're basically saying our total orders counts the distinct orders within the sales data table. In a text form, that's how this total order measures translates. So taking a closer look at our data view here, we're looking at the order number column within that sales data table, and it's sorted by order number. You'll notice right off the bat that the same order number can appear multiple times. So there can be multiple instances of the same order within this column. So in this case, we're looking at order 74144. That order appears 2 times. So this order took place on June 30th, and it actually contained 2 different products. So this customer, when they came in, made this purchase. They bought 1 quantity of product 574 and 1 quantity of product 220. And because we're calculating a distinct count, that only counts as 1 order number, even though it contained 2 different products. So to kind of follow this chain of relationships here, we can actually think about what these product numbers actually represent. So we've got our order number here, 74144, and you can see we've got it for 2 line items, product 220 and product 574. Right, so let's start here with product 574. We're going to go over to our product lookup table, and we're going to look for 574. Right, sort our product key here, come down. Right, we've got product 574, and we can see that this is a touring bike in blue. Right, our product subcategory key for this product key is 3. So next, same logic. Let's go over to our subcategory lookup table. Product subcategory is 3. We see that it's touring bikes, and our product category key equals 1. If we jump over to our product category lookup, product category key 1 equals bikes. Product 574 should be labeled or categorized as bikes. Now, I won't go through that same process for the other key, but if you want to practice, feel free to go ahead and do that. But I'll tell you right now, product 220 is a helmet, which falls into the accessories categories. So when we're looking at this 1 order number, it counts as 1 distinct order for the total, And it also counts as one distinct order for both accessories and bikes. So as you're probably starting to realize, this one order number contains products that fall into multiple different categories, accessories and bikes, and it's part of the total row. So when we look back at our matrix visual here and think about how the total order measure is evaluating, when we're filtering down to our accessories categories, we're seeing one order from this particular order number that contains an accessory product, right? When we filter down on bikes, we're seeing another order. But when we evaluate the total, we're basically looking at an unfiltered version of this sales table. There's no context to define our category name. So when there isn't a filter applied or there's no filter context, we see that we have 25,164 total distinct order numbers. So kind of tough to wrap your head around, but that's exactly what's going on here. And one way to kind of interpret this or read the numbers from the matrix is that the accessories or products in the accessories category appear in 16,983 orders. Products that fall into the bikes category appear in 13,929 orders. Same thing for clothing. So the key point here is that it is critical to understand exactly how the functions you're using in your measures are calculating and what they're designed to measure. This is really a nuanced point, but it's critical to understand as you're continuing to learn the DAX language.